The environmental gold standard, or holy grail if you prefer, is solar energy for electricity and hydrogen for transportation. The sun is the most powerful energy source available. Solar energy heats the world's oceans, creating clouds and rain in a never-ending water cycle. It also created the world's fossil fuels, coal, oil, and natural gas, which give us electricity. It can also power and heat our homes and workplaces. Hydrogen is an extremely high-quality form of energy, like electricity, which can be stored in large amounts and transported to where it is needed, to be used when it is needed, and when combined with oxygen, it produces energy as well as water. The conventional wisdom is solar is intermittent. Since the sun doesn't shine at night, we need a way to store solar power. While this technology exists, it costs millions of dollars, and you still need another source of power due to the sun's intermittent nature. In terms of the hydrogen economy, the same conventional wisdom points out that hydrogen is not a primary energy source. It is an energy carrier and not a very convenient one at that. Hydrogen's detractors claim there is no good way to produce hydrogen. Oil and natural gas are potential hydrogen sources, but their costs are already high, and it would be counterproductive to develop expensive new infrastructure that is dependent on a rapidly depleting resource. Coal is a potential hydrogen source also, but energy efficiency and environmental degradation make this prospect unsustainable. Electricity derived from wind or solar is another potential hydrogen source. Hydrogen's detractors, however, claim it is crazy to use wind and solar electricity to make hydrogen, while fossil fuel is used to make electricity. It is better to use wind and solar-derived electricity to free up fossil fuel. Hydrogen is produced from the freed-up fossil fuel. The rationale is you get 2 to 3 times more hydrogen production from the same inputs, keeping in mind the goal is to eliminate or reduce fossil fuel dependence. It is also claimed there is no good way to store and distribute hydrogen. The consensus is hydrogen must be liquefied or compressed to be useful. Hydrogen tanks are expensive and heavy, and liquefaction or compression requires considerable energy. Moving hydrogen via conventional pipelines or trucks is also said to be impractical. Hydrogen-powered vehicles using fuel cells are also currently expensive, as is the case with virtually any new technology, and so too have there been technical difficulties. Finally, there is the issue of distribution infrastructure, of which in the U.S. only a few hundred miles of pipeline carrying industrial-grade hydrogen currently operate at relatively low pressure, and there are few hydrogen refueling stations. So much for conventional wisdom. Public apathy, the undue political influence or entrenched interest, name your poison, has gotten us to where we are today. While the Kyoto Protocol bound 37 industrialized countries in the European community to reducing greenhouse gases by an average of 5% against 1990 levels over the period 2008 to 2012, those levels have continued to rise, with the consequence a recently published study by scientists from the Canadian Centre for Climate Modelling and Analysis at the University of Calgary point out that even if we stop putting CO2 in the atmosphere today, there will still be cataclysmic climate change. Sea levels will continue to rise by about 4 meters because of the thermal inertia of the oceans.